Okay. So welcome to the session on EVM Wallet Basics. What I'm going to talk to you about are the different kinds of wallets that actually exist. I am not talking here about the software, hardware kind of wallets, but more at a tech level, what are the kind of wallets that we have? So the first and the most common is what we call as a single wallet. Now, what you've got to understand is when we use this term wallet in crypto, we are talking about something which is holding your addresses, your private key, as well as in some cases your public key, depending upon the chain. And sometimes you also have a QR code, which is basically just a graphical representation of, say, your address. So the word wallet is actually very easy to confuse because in real life, when we say wallet, we are talking about something where assets are held. But in crypto, assets are not held with you, they are held on a chain. So what you actually hold in your wallet is not the asset, but you are holding the private key which controls that asset. So if you want to send that asset to somebody, you have to sign a transaction. You sign that transaction with the private key. When someone wants to send you any token or crypto, they have to send it to your address. So this process of creation of the wallet happens with an algorithm at the same time, which means it is going to generate the private key and the public key and the address at the same time. You cannot take an address and try to generate its private key. That's not how it works. You can take a private key and generate the address, but not the other way around. I hope that part is clear. Whatever questions you have, just keep putting it in the chat. Now let's just click here. Now you have this HTML file with you. You can run it locally on your system. Later, you can disconnect the internet and still run this file. That's why I've given you an HTML file. So it is not connecting to any other server. Of course, please don't disconnect your internet right now. Otherwise, you'll drop out of the Zoom session. But later, I want you to try that. Now, when I click new address, as you can see here, the public address or the address as well as the private key are changing and two QR codes are being generated which represent those. So if you try scanning the first QR code, it shows you the address. The second one is the private key. So you use the QR code to share this, but this becomes something you can share with the whole world. And this is something that you would never share with anyone. Any crypto sent to this address can only be controlled by this private key. I hope this part is fairly simple and clear to everyone. Now we come to this concept called a paper wallet. What we have to ultimately remember is all these crypto wallets, addresses, keys, they're just alphanumeric strings, which basically means at any given point of time, you can write it on a piece of paper, you can take a printout, you can take a photo, you can do anything. It's the same thing. It is not that it has to be stored in a software. It can be stored on a piece of paper. Now let's take an example that I'm generating 3 keys. Now, the moment I do that, it is generating 3 addresses, and with each address, there is a corresponding private key. And now, if you want, you could just click, say, this print button, and you could take this print out on a piece of paper. And this is the simplest and the most secure way in the world to hold crypto. When you hold this kind of private key on a software, there is always a risk that the software may get, your computer may get hacked and someone can steal that. If you hold it in a hardware wallet, there's a risk that the wallet may get damaged. Somebody may steal the wallet. But when you put it on a piece of paper, you can hide it very carefully. And unless someone physically breaks into your house, they are not able to get your credentials. I hope this part is clear to all of you. Any questions? Or just give me all clear so I know that everything was simple to understand. Now we'll come to a slightly more advanced version. Just drop me an all clear. Yeah, perfect. Now this is an interesting concept which is called as the seed phrase wallet. Now, earlier what I've just been showing you, we say that we generate a private key. From that private key, we generate an address. But now we have a system where first we generate a random bunch of words. And from that random bunch of words, unlimited wallets can be created across a lot of chains. Let me give you an example. So let's say as of right now, we want to derive 3 wallets. So I just click here. Now what my system has done is, firstly, it has generated 12 words. Now this is the simple code I've given you, so it generates 12. But if you were to use C4 Lab, for example, the tool, it could generate 12, 15, 24 different sizes because all of them are supported. Now the words that are here, they look random to you, but they are selected from a predefined list. So there is this BIP standards which are there, and under those standards, we are deriving or we are using words from a pre-selected set. So there is about 2048 words which are pre-selected. From those 2048, our software has randomly picked up 12. Once it picks up those 12 words, it can then derive as many wallets as we want. Now, in this session, I won't go deeper into what this M44 and all that means. That's more advanced. Today, we'll just do the basics. Now, once it has derived these uh, words that you can see, it starts to derive wallets. So because I said 3, so it gave me 1, 2, 3. Now, let's say instead of that, I say 5. I regenerate. Obviously, the seed phrase has changed. And now it shows me 5 wallets. Like this, I can generate unlimited wallets. I can say 5,000 and it'll generate 5,000. Now, if you've not used MetaMask, whenever you try it, you must try wallets like these. When you go to MetaMask, what it does is, right in the beginning, it generates these 12 words for you. This is called as a seed phrase. Once those 12 words are derived and you go into a MetaMask wallet, the first wallet is created for you like this. So the first one would be there, and that's the one you can use by default. Now, when you ask it to create the second one, it will create something like this. And every time you tell MetaMask 1, 2, 3, 4, it'll start creating more. But all of these are derived from the same seed phrase, which is why MetaMask will always tell you, please keep your seed phrase very, very carefully. If you lose these words, then you can never recover any of your wallets again. Your crypto is lost. If you securely keep these words, you can go to any other wallet like MetaMask in the world on another computer. If you enter these same words, it will generate the exact same wallets in the exact same order. Of course, there are other parameters that we can tweak like this 44, 60, but for today, let's just presume none of that exists. So as long as you are using the same seed phrase, you can go to any other MetaMask in the world. It will generate the same addresses in the same order, because the order is also very critical here. Now, another beautiful thing here is when it's an EVM address, it is going to work across all EVM compatible chains. So whether that's Ethereum or Polygon, it is going to work on all of them. This address will not work obviously on Bitcoin, but the same seed phrase can be used to generate unlimited Bitcoin addresses also. So once you have created this seed phrase, you can go to different wallets or or you can use your own software. For example, I teach a lot about Python and how you can make your own wallet in Python. I'm going to be doing a session on that very soon. You can join that. So I'll show you in that from the same seed phrase, you can generate unlimited wallets for Bitcoin, Bitcoin Cash, Tron, you name a chain, and it all comes from those same 12 words. I have a question. Apart from generating the wallets, does it also indicate which chains they belong to? So that's a very good point. When we look at these 12 words, the 12 words do not belong to any chain. However, when we look at these wallets, yes, there are some ways we can make out. So for example, when we see a wallet starting with 0x, well, we know that it is going to be an EVM compatible. Now, similar to this tool that we are looking at right now, I've made similar ones for Bitcoin, Tron, and Solana. So when you look at a Solana address, it starts differently. Bitcoin starts differently. Tron starts differently. So we can kind of get an indication about which kind of address it is. Having said that, once we know it's EVM, the same address is going to work across all EVM chains. So if you were doing an investigation, then you would investigate the same address on multiple chains and then see whether any transactions have taken place. Or this confirmation I can only do on my MetaMask. No, not necessary. You don't have to use MetaMask for it. Like I said, you could write your own Python script, which functions like a full-fledged wallet, much more secure than MetaMask is. Because when we talk about things like MetaMask, ultimately there is a third party who has built a software. That third party is collecting a lot of your information, including your IP addresses. If you look at the help file, they mention all this clearly. But when you create your own wallet in Python, you can actually send transactions from it. But everything is securely kept only on your laptop. Your keys, nothing ever leaves your system. I hope that part is clear to all of you. So we can say that this 12-word seed phrase is like a master backup from where all your keys can be regenerated. Now, this derivation path makes a difference, but like I said, today I won't go into that concept. This is the basics of a wallet which is generated from a seed phrase. One phrase, unlimited wallets. Now let's look at, let's say we want to generate multiple wallets at the same time. You could just click on generate bulk. And what it's doing is you can even export this in a CSV. and you are generating multiple addresses along with their private keys. So it's just a very simple concept. Instead of one, we are doing multiple at the same shot. Now, if you were to use this particular tool in a real world scenario where you are going to actually use those wallets, then always disconnect your internet so that you are 100% sure that nobody is stealing your key. So that is why I told you this is an HTML file. All the libraries that it needs are inside the file. So open up the HTML code. You can read through the entire thing. It's a very long code. And then you can understand what is really happening. All the JavaScript files that are needed to do all these creations are embedded inside the HTML file. There are so many EVM protocols. Do you think there's a difference between them, for example, in security and risk of contamination when using seed phrase? So that's a good question. So when we look at EVM chains, there are of two types primarily. There is a layer 1 and a layer 2. Now, when we say layer 1, we are talking about Ethereum, Polygon, for example. Then there are layer 2s which run on top of the layer 1. So the logic being that why this started earlier, Ethereum was the only VM we spoke about, right? Now it used to be slow and it used to be very expensive to do transactions. So somebody came out with this idea, let's run a layer 2 on top of it. All the transactions will happen in layer 2, so it'll be fast and cheap. From time to time, that layer 2 is going to bundle a bunch of transactions and dump that onto Ethereum. So the cost is very, very, very low. That's how L2 started. But today you have a lot of L2s which are very, very popular also. As of today, we've not really found any difference in terms of security because everything is today built on these open source models. They've been tested by the best experts in the world. And as of right now, we have not identified any scenario where there's a vulnerability. So you can use the same phrase and generate wallets across all. But try to remember this. The seed phrase is not going to anyone else. So using the seed phrase, when I generate a wallet address, the blockchain only knows about the wallet address. The blockchain does not even have my private key. When I send a signed transaction, the blockchain can confirm whether I use the correct private key to sign. That's all it can do. So the blockchain never sees your seed phrase or your private key. It only sees your address. So the blockchain's vulnerability doesn't really impact you. Wallet address generated if searched on blockchain, what will be the result? So right now you can in fact try it. Because we've just created this address, it has no transactions. So when you go to the chain, it will just show blank transactions. If you actually send crypto to one of these, then it will show up as a transaction. Blockchains do not really show you anything unless a transaction has actually happened. Apart from single wallet generation, do you have a tool which supports multi-sig wallets? Well, I haven't built it in this, but sure, that's easy. I'll note that down. That's a good idea. And maybe I'll add that to this tool. I'll add multi-sig. That's a good suggestion. Any questions so far? Okay. Now we're going to see a very different kind of wallet, which we also call as a brain wallet. Why we call it brain wallet is because in your head, you just have to remember some phrase, some sentence. So let's take an example. Why don't one of you just give me a simple small sentence which we can use to create a wallet? Can you just type in some sentence? Okay, this is cool. So let me type it. Now I say this is cool. And I say derive wallet. Now it has derived an address and derived a private key. Now, if some of you have got this tool open on your laptop, I want you to go to this brain wallet part and I want you to type in this is cool and tell me whether the exact same address opens up or not. So I'll give you guys a few seconds to try that out. Till then, I'll answer this question. How does the blockchain know how many wallets are there for a particular phrase? The blockchain doesn't know that. The blockchain actually knows a protocol. So when you enter in an address which is matching that protocol. So for example, in EVM, it's starting with 0x, the alphabets, numbers inside, they're not random. They're all, if you realize, there's a rule on what actually can show and not show inside this. So the blockchain knows the protocol. When it looks at it, it can tell you whether this is valid or not. And then it checks, has this address ever made a transaction in the past, yes or no? So it does not have a predefined list of every address in the world because there are unlimited addresses. I mean, trillions and trillions and trillions and trillions of addresses can be made. So nobody has made a table of that. Like in the world of domain names, we have a table of every domain name in the world which is registered. Similarly, the blockchain only knows those addresses which have undergone a transaction, data is stored, If it has never done a transaction till today, the blockchain doesn't even know that that address exists. Now, all of you have said same address because we are using the same algorithm, the same mathematical formula to convert this is cool as a word into an address. If we use something different, now I want you to try this.
If we write in the uppercase, this is in lowercase and cool in uppercase, the address will be different, sir.
Let's try it out. Absolutely. So let's say I don't put a salt. So I made the first word capital. You can see this. Immediately you see that this changes because whether it's small letter or upper letter, they are different. To the computer, every symbol is going to be different. So if you put one extra space, you put a dot, you put a hyphen, you change the input by even one thing, obviously the address completely changes, the private key, everything changes based on that. But what I wanted you to understand is no matter which software you use, as long as we are using the same protocol, the same mathematical formula or algorithm, it is going to generate the same wallet for you. So this becomes a way in which, suppose a group of us want to share the same address for whatever reason. We don't have to remember these complicated 12 words. We can just think of a sentence, which normally people don't use, but between us, we have decided on a sentence or even a word, and we can generate this. But please remember, this can be broken also quite easily because then you can easily do brute force. Trying to do brute force of those 12 words is impossible as of today's technology. It will take trillions of years. But brute forcing a small sentence or a word is very easy. So while brain wallets are easy to make, they're also easy to break. Now we can add some level of complexity. We can add a salt. So for example, I can write 1, 2, 3 as a salt, ABC. It is going to further complicate the process. So it makes it a little more difficult for people to crack. So with this is cool. When I use 1, 2, 3, I get something. When I use 1, 2, 3, 4, something else comes. But now again, I want you to try it on your system. For this is cool, please enter 1, 2, 3, 4 as your salt and then tell me whether you are all getting the same thing. Will not the address clash if we use the same password? So it's not clashing per se, but yes, all of us are now using the same address. We are using the same private key. This can happen if we all use the same passphrase to start. So if I guess someone else's passphrase, I can get his private key. So there are many people who actually try this and some people make money from it. What they do is they write scripts which will take all these different kinds of common words, phrases, movie names, all sorts of things, generate the addresses, then check immediately on Bitcoin and other blockchains, has that address, does it have money? And if they find it, they can immediately steal your money. People are actually doing this. So what I want you to understand is brain wallets are easy to make, but they're also easy to break. Unless we come out with a very complicated sentence. In that scenario, it's better to use a seed phrase. So seed phrase, passphrase, salt bring extra layers, but have not seen. Okay. Now in this iteration, suppose I add one. So it's 60,000, whatever. I add one to it. I hit enter, again it changes. So iterations is another layer of complexity I can add to make it a little more difficult for someone to crack it. Is this not a vulnerability? No, actually it's not. That is the system on which crypto is made. Now let me explain to you why this is not a vulnerability. If we take all the computers in the world and we run them to crack one random seed phrase, it will take trillions and trillions and trillions of years. And that is considered impossible. And that is why it's not a vulnerability. In fact, have you heard about SSL, secure socket layer? In fact, if you look at any website, you will see that there is HTTPS written there. What is that? That is the exact same thing. We are using the same concept, right? Which we call as encryption. So there's symmetric and asymmetric encryption. It is being used since the 1970s for all kinds of secure communication until today. Those algorithms have not been cracked. And we talk a lot about quantum computing. When that comes in, if that comes in, then we may be able to crack. But when by then we will just make the algorithm more complex. So as of today, I want you to remember this is not a vulnerability. This is the design based on which it is built. So question is, when I come across the passphrase at the scene of a crime, must I search for the salt or how will I know that the salt has been added? Very good question. So if it is a savvy criminal, you're never going to know that he used a salt or not. But most people don't use it. And most of the tools you find online will not even mention the salt. They'll just tell you to enter a passphrase. But if it's a savvy criminal, he wouldn't even use this. He'll probably just use the 12 words. But of course, depending upon the investigation, we can crack it. Physical investigation comes into the picture. But for now, I want you to understand that a passphrase may have a salt and it also may have iterations. So we need to keep that into account. Any questions? Okay. Then we have from an address, we can find an address with a chosen prefix. Now, this is a very interesting concept. So I want an address which is not just purely random, but it starts with certain number of things. So suppose I say C4 and I say find a wallet. Now what my system did, if you look here, after 375 attempts in 0.39 seconds, it has created an address which starts with C4. And for that, it is giving me the private key. Now, suppose I want to make it more complicated and I want it to start with the word cafe. Now, we can use the word cafe and now it is going to take a lot of time to do this calculation. So it says, can you see here how many attempts are being made? Right now, I'm running it on a normal laptop, so it does about 1,000 addresses per second. And it is expecting to take 65,000 attempts to create one wallet which starts with the letter CAFE. So this barely about halfway through. In fact, I want you guys to try it on your system. Enter in the word cafe, start it. If your laptop is very powerful or you're using it on a powerful server, it'll work faster. Why don't you guys try it and in the chat tell me what speed it is showing for you. Like right now, my speed is showing at 1134 addresses per second. Type in what your speeds are showing. Is anyone getting it faster? So we've reached about 56,000. Someone's getting 715. Okay. Someone's getting 400. Okay. 630. Anyone else on a Mac? Because Mac gives me right now 1100. So it's expected to have finished in 65,000 attempts, but it's still not finished. So it will keep on working. If anyone else has a Mac laptop, you could try it. Maybe you'll get the same speed. So you see, it's reached 84,000. It is still not found a valid wallet. And now it has. So after 88,000 attempts, which took 77 seconds, at a speed of average of 1142 per second, it has generated a vanity address. So vanity address just basically means you are trying to show off. Like for example, people pay extra money for the registration number of a car. And sometimes you pay more than the cost of the car itself. People pay lakhs of rupees because they want a very cool number. Like somebody wants 1 or somebody wants 9 or whatever. Same way, if you want a cool address, then you could do something like this. So again, you don't have to pay anyone for it. You use a powerful system and you run a software like this, and it'll keep trying till it finds a working, valid wallet for you. Now, I have a question here. Instead of cafe, can I write anything else? What do you guys think? Give me an answer. No. So what are the limitations? Like what is it that I can and cannot write here? Anyone? Can we say vanity wallet generator enables you to customize your wallet? Yes, you are customizing. Yes, absolutely. Yes. So now suppose I try my name here. In fact, I want you guys to try it on your system. You try ROHAS. And it says enter a lowercase hex prefix between 1 and 6 characters. So we have to enter hex only. Now hex means 1, 2, 3, 4, 5, 6, 7, 8, 9 or 0 and then A, B, C, D, E, F. Only till then. We cannot do more than that. So suppose I say, like I said, A, B, C, 1. Now I can work because A, B, C, 1 are supported, right? If I try writing here a Z, it is not going to be supported. So only hex is supported, 0 to 9 and A to F. Only those alphabets, but then you can put them in any kind of an order. So suppose I say I just want ABC. It's done. The lesser number of I put, the faster it happens. So when I say just A, it'll happen instantly. ABC, still very fast. So ABC is now taking some time, but it's done. If I say ABCD, now it takes more time. So the more the numbers I add here, the slower and slower it is going to get. Is that part clear? Just to be sure, and perhaps, did you create this tool? Yeah. So, I mean, I used a lot of open source JavaScript libraries and put them into an HTML file. So no, I wouldn't really take credit for the tool. I used open source libraries to make this tool as a simple way for you guys to learn. But if you want to see some of the tools I've made, you can log in and check out C4 Lab. There, I've made a lot of very interesting advanced level tools. Is it better to use a mix of special numerical uppercase? Yes, it would always be better. So you are talking about a passphrase here. So instead of say, this is cool, I could say maybe a capital T here and a full stop at the end. So what sometimes people do is they will pick up their book, favorite book, and open up a random page, say page 6, and then they will type out one sentence from it. Now, this kind of a brain wallet is much tougher to break. But again, people are smart. So a lot of hackers, what they have done is they have taken all the world's most popular books, all the Bible, the Harry Potter books, all the famous books, and they have created brain wallets for all the sentences and words, trying to make out if someone has used it, and then they can empty your wallet out. But if you create a sentence which no one can normally guess, like if I was to say this is cool, maybe a software can guess it. But at the end of it, I put something like ZXY. Now this becomes very difficult for anyone to guess. So anyone trying to crack this kind of a brain wallet, it would be very difficult. I hope that answers all your questions. Now we can start with a private key and calculate the address. So let's say we start with this private key here, right? So I copy this and then I say, okay, I have a private key. I want to know what address it belongs to, and I can do that instantly. Please remember, I cannot go the other way around. I cannot give it an address and say calculate the private key. That is not possible. And if that was possible, then all crypto in the world would be broken. So as of today's technology, we cannot do it that way. But once we have a private key, we can instantly calculate its address. Is it clear? Now, one thing I always want you to remember, whenever you are creating your own wallets, always do it offline. That means switch off your internet connection and then only do it unless you have gone through the code and you know that there is no bug or hidden door in the code. So even if you're using this code by me, I've used third-party libraries. I would recommend switch off the internet, refresh a few times, click multiple times, and then pick the key and store. And then you can close the tool. So that's one of the simplest and best ways to create your own wallets. Now, very soon, I'm going to be doing a series of sessions around Python, and I'll explain to you why Python is very important today for everybody to know. See, what I've shown you right now, it uses HTML and JavaScript, which is good, but it is limited functionality. Python, on the other hand, is very easy to run, but we can build virtually anything in that. So we can build our own fully functional wallet, which can work even better than, for example, MetaMask. So I definitely recommend all of you guys to attend those sessions. Also, I'll let you know on the group itself. Any questions before we end the session? Now, just like this on the group, if you want, or you can message, I'll give you similar files that I made for Tron, for Solana, as well as for Bitcoin. Because in Bitcoin, it doesn't use the same algorithm. The keys look different. Same in Tron, same in Solana, they look different. Bitcoin supports different algorithms like SegWit. That is why we need different tools for different chains. All EVMs in one, Bitcoin in another one, Tron in another one, and Solana in another one. Really interesting. Thanks. Okay. Yeah, I'll be putting this. So sometimes I do keep uploading on my YouTube, but then I many times forget. But I'll definitely put this up on YouTube also. Any good source to learn basics of crypto and connected? Sure, I'm a very good source for that. So, like I said, I'll share more of these with you. So after those 4 files, you'll be very comfortable with the wallet part. And I keep doing a lot of free online sessions. So if you attend them, you won't really, don't worry, you'll learn quite a bit. Yeah. Okay. See you guys. Have a nice weekend. Bye-bye.
Thank you.
Yep. Welcome.